Hello, everyone. This is Bill Stone, Professor of Pediatrics at East Tennessee State University in the College of Medicine. We have two objectives before us today. The first is to draw the structure of L-Glutathione, abbreviated GSH, using the Marvin sketch applet. The second objective is to explore the chemical properties of the glutathione once we have drawn the molecule. And for both these tasks, we'll be using a wonderful new web page, www.chemicalize.org, developed by ChemAxon. And we're going to start by going to Edit, bring up Source, File, New, and we're going to type in the sequence for a simple dipeptide, which would be cysteine glycine. We're now going to import this as a peptide sequence. And there we go. So this is the notation for cysteine glycine. We now want to insert a third amino acid residue, which is glutamic acid. We're going to do that here. Insert. We're going to go to the template library, bring up amino acids. Let's open this up a bit, and let's go to glutamic acid, close, and we'll put that glutamic acid right here. Now, these notations aren't very useful, so what we want to do at this point is go to Structure, Group, Expand Groups. So now we can see more of the organic chemistry of what's going on. Now, glutathione is a tripeptide, but it's a tripeptide in which the glutamic acid group is connected to the gamma glutamic acid carboxyl group is attached to this amine group of cysteine. So let's make this bond. There we go. And this, of course, looks a little bit strange, so we need to go to Structure, Clean 2D, and now we have something that looks much more reasonable. But notice we're missing the OH group here. Let's do that. Click on oxygen, make our bond here. Now we've inadvertently changed this to a oxygen. Let's go back and put it as a carbon. There we go. Let's clean the structure once more. There we go. We have a funny looking wedge bond there. Let's go to Structure, 2D, Clean Wedge Bonds. And there we go. Now we have the structure of L-Glutathione. We can save this, and we want to save it as a SDF file, which would be here. And the reason we want to save it as an SDF file is that in a later YouTube I will demonstrate how we can use that L-Glutathione SDF file in protein ligand docking. Okay, once we have the correct structure drawn, we can now explore the properties of glutathione. We'll do that by clicking Property Viewer. Before I leave this page, I want to point out that there's a quick start guide here that's useful to view. Let's click Properties Viewer. And here we go. So we are now viewing the properties of glutathione. This is the molecule that we drew. First thing to notice here is under major microspecies is that at pH 7.4, this would be a negatively charged oxygen and negatively charged oxygen here, positively charged amine group. This is important because if we do docking later on, we want to make sure we have the proper charges on the molecule. This is the geometry of the glutathione molecule using a Drying energy force field. Again, useful for docking later on to have the energy minimized structure. I won't go into each and every one of these because they're explained in some detail wherever you see a question mark. This panel is Lipinski-like filters. This is very useful in drug discovery, drug design. If you want to know more about this, we can click question mark, and now we have the definition of Lipinski rule of 5. Again, we'll be going into this in further detail in later videos. One useful thing to notice here is we can download our results, again very useful, and we can use these SDF files later on for protein ligand docking as well. We have links to other web pages. Here's a patent utilizing glutathione. Here's one antioxidant, looks interesting. And here's one glutathione, the mother of all antioxidants. Glutathione is the key intracellular antioxidant. We'll also be discussing it more later on. Thank you. That should do it for today.